I've been getting this question a lot recently, both online and offline, is how do I get started? What can I do to get going? And things like that. And that can really be a tough topic because I don't know everybody's situation. So this is going to be an overview, sort of going to detail the path that I took to get started, but we'll see how it goes. As with everything, if this video generates a lot of questions and comments, perfect, and look forward to conversing with everybody in the comments section down below. So, a long time ago, for Christmas one year, I got one of these, and I know some of the viewers of my channel are going to see this book, and it's going to give them flashbacks. This is actually the book that I got with the kit that I was given, and unfortunately, these kits really aren't given anymore, but also not a lot of stuff is individual component based anymore. So the best place to start with starting in electronics is getting a very good understanding of Ohm's law and voltage, current, resistance, and power. Everything is driven off of those. Without a very solid foundation, this stuff is already clear as mud, even to myself. And without a solid understanding of what's going on, it's worse than opaque. The nice thing about these books, and why I'm showing this book specifically, is I did find a place online where you could, if you Google 160-in-1 PDFs, all of these have been scanned and digitized and are available for download off the internet. Now, the really nice thing about this is this was the particular unit. Had little springs where you hook the wires up and things like that, but it has a schematic, and then it has a circuit definition of what some of the components are doing. So this lets you build a circuit from schematic on a breadboard, something like that, and we'll get into basic tools a little bit later in the video. A lot of the stuff here is battery operated. Batteries are okay, but I'm going to kind of take this video from the stance of someone who has decided this is for them, and they're going to invest a little bit of money in getting started. Some of the gear that I'm going to recommend later in the video, I'm not going for the cheapest of the cheap, as I am someone that has to make my living with tools in hand. I have seen what cheap tools do on the job site and things like that, and the worst investment I have ever seen anybody make, other than literally setting money on fire, is buying cheap tools. That is not to say you do not need to buy the most expensive tool on the planet. Absolutely not. I was on a job site that we had to provide our own tools, and someone showed up with a complete toolkit from the dollar store. It was a full tool bag, full complement of what I would consider a basic set of hand tools, but I think the whole thing cost them $5. What ended up happening was they didn't last the shift. At the end of the shift, which was only 8 hours, they had a screwdriver that hadn't snapped. Everything else was broken. So they really did not help, or did not hold up. Tools are an investment. I have been working on the tool collection since a young one coming up, and that has served me well throughout life substantially. Saved me a ton of money in the long run. The buy-in does tend to be slightly steep. Reasonably decent tools are somewhat expensive. But, so, you can pick up one of these books. If you pick up one of these books with the part set that you got with it, obviously you won't have one, so you will need breadboard. So this is a Lenco Precision Model 9440. This is a rather big breadboard. Sometimes they're single units, things like that. The holes in this is great for prototyping. You can put ICs across the center rail. You can build some pretty complicated stuff on breadboard. This particular one is set up for plus minus 15 volts, and then with a 5 volt supply and a ground. That is for, I was working with op amp circuits Yeah, TLO 72s. So I was doing a little bit of experimentation with op amps, which is why on this one I have it configured for the plus minus supplies. Very rapidly, that's going to get me into item number 2 on the list, which is going to be some form of power supply. Now, some of the things that I'm going to recommend are going to be should purchase new. Some of them aren't necessarily vintage, but functional is fine. Power supply is one of those where vintage but functional is fine. Here are the 2 main power supplies that I use on the lab regularly. I have some other fancier power supplies on the other side of the bench, but a Rigol DP832A, that is on the more expensive side of power supplies, triple output. What is that, 30 volts, 5 amps, I think? No, 30 volts, 3 amps with a 5 volt, 3 amp supply. The nice thing about that is it is variable. I also really like this model TP343B because, as you can see here, this particular one has a dual tracking mode, so I can flip this over here and I can set this for plus minus supplies. This is the common ground right here, and as you can see, common when tracking. So this is ground, then I have DC plus and DC minus. This is a great setup for working with op amps, both things in one supply. One knob controls both units. And then I also have a 15 volt supply, 6 volts to 5 amps or 15 volts to 2.5 amps over here for additional voltage. So really am a fan of this supply, especially as a bench supply and a lab supply. It's rather large for a 3 volt supply, or a 3 rail supply, but I do like it. The reason that supplies are used but functional and not new is due to the fact that I can set the supply with a DMM. So if I don't need these dials to be 100% accurate, and I really shouldn't trust these dials anyway. When I'm setting the voltage on these supplies, I'll hook up a multimeter and set it with a multimeter, not necessarily with the meters on the supply itself. I use those as a guide, multimeters more accurate. The next piece of gear that I want to talk about that's going to be a basic piece of gear is going to be a DMM. DMM is going to be great for setting circuits, looking at resistors, setting power supplies, doing measurements, tracking things that aren't moving too much. Obviously it's DC, although the AC mode of some DMMs end up getting, they're getting pretty accurate. But I'll scroll down just a little bit. In the shot right now, there are 10 DMMs and 2 analog multimeters in the shot. So the 2 analog ones are here. This is my daily driver, 6500. I would not recommend buying this as a first meter. This one, the cost is substantial, especially if you're just getting started. Up here, however, we have a bank of 8 DMMs, and then I also have a Fluke right here, which is another DMM on the bench. Now, this Fluke 179 was my go-to meter for a long time, long before the bench started. I was running around with this. This actually was in my tool bag. This has seen some abuse. I want to say the 122s were the other one. They're a clamp style. This served very well for a long period of time. Since we're taking this from a getting started with doing circuits, a Fluke meter isn't necessarily needed. If I was going to be doing an industrial application, say maintenance technician, something like that, I would start carrying what brand this was, especially if I was sticking the probes in a high power electric panel. I'm gonna do a Fluke, a Gaussian Metrowatt. There's a couple of more brands I'd go with, but the names of which temporarily escapes me for industrial power. But for circuits, low power, not mains derived, not mains rated. The brand of meter is not necessarily of critical importance. However, its accuracy is. So if I'm measuring something on a circuit, I want to know the meter's not lying to me, because if I make a mistake, especially when I'm learning something, I want to know my equipment. I want to have confidence the equipment is showing me the correct thing. So if I make a mistake, I'm not questioning the measurement device. I'm questioning whether I've done something wrong. Am I probing it correctly? Do I even have the board set up correctly? I don't want to be questioning, is the ruler working? A good DMM, especially in the beginning, a reasonable one for this, around the $100 price point to get started. And also, you'll probably want two, because you'll want to do voltage and current, because you can't do both of those at the same time on the same meter. So to watch voltage and current, you'll need two DMMs. They do not both have to be the same, of the same caliber. You could buy one good one, one quote, lesser one, and be okay. The other thing is to know what current range you're going to be working in. So this particular meter can give me 10 amps. However, even though we go up the meter line in precision, I don't want to say quality, because these are both quality meters. They're just for two different purposes. But as we go up the line in precision, we actually go down in amperage. This can only do up to 3 amps. These bench meters can only do up to 1 amp. So that's a definition that you'll need to work on, or you'll need to know, is what's the current ranges I'm expecting to run into. Even 3 amps, depending on the voltage, can be a substantial amount of power. 10 amps is a substantial amount of power. My bench power supplies can't even deliver 10 amps. So that is something to be taken into account as well. Now, if you do end up going the used route for meters, which I've done, obviously, that was used, these guys were used, things like that. The reason I was able to do the used meters here is because I was able to calibrate these in-house. If you're just getting started and you're grabbing some stuff from eBay or from auction websites or something like that, the calibration should always be in question. So you'll need some way to check the meter to start trusting what it's telling you. Now, one of the ways you can check those, at least to the specifications of the device, would be, there's some, I think the boards are the DMM Check Plus, which will get, I might do a video on those. We'll smash them against the 7.5 or maybe 8.5 if I end up getting that high digit meters. I don't have an 8.5 in the lab yet. 7.5 is where I top out. Or a PDVS2. Ian Scott Johnson, a fellow YouTuber, he's created a PDVS2 Mini. It's a precision source for calibrating meters, things like that. It would be plenty to calibrate these meters. When you're for the PDVS2 Mini, on this one, you're starting to really run it up against its specification. Same thing for the 7510. But for these 3.5 digit, I mean, even for this Fluke, the PDVS2 Mini could very easily calibrate the Fluke, at least in the DC ranges. And you could do the AC ranges are kind of a little bit more difficult. And that's where a lot of labs kind of fall off. But for getting started, AC is less critical. DC is more critical, because that's what you'll be working with in the beginning. The next piece of gear to get started is going to be a oscilloscope. It is, it is the quintessential device for looking at circuits, figuring out what they're doing, and things like that. The problem is a chicken and the egg thing here. I can get a cheap oscilloscope from eBay, of which I did. Actually, it was this one right here. I think I paid $100 for this. It's a it's a Fluke 485, 350 megahertz scope, 50 ohm inputs. However, I've done a lot of scopes on this channel, and I've done a lot of stuff from secondary market on this channel. Every single scope that I have purchased secondary market that has been inexpensive has needed alignment and calibration. It has not been ready to go. That is not to say an analog scope cannot be done from the secondary market. However, if you're going to get a scope that's calibrated, it's going to cost about as much as this scope right here, or more, depending on the speed. So I do a lot of the alignments and calibrations in-house. If you have questions as to what that entails, check the backlog of videos in the channel. There's a substantial amount of content on getting these scopes up and running. So you'll see into some of the challenges that I've had to overcome to get this stuff going. This scope still does not work to factory spec. It's the only thing on my bench that's not in nope, I take that back. There's two things on the bench that are not in factory spec. This scope and my 284. I'm still working on the 284, but I have used it in a couple of videos within where I could validate it, but I haven't, dusty, where I haven't calibrated it yet. These light shields, these are just 3D printed. Thingiverse has these if you're curious. So other than that, everything else on the bench is running at factory spec or better. A good scope, I personally, if I'm starting a lab, I would not go under 100 megahertz. I would even maybe push it to 250 these days. I'm really running into some limitations with this scope. It's a little slow. It's not the scope's fault. I picked a 100 megahertz scope, and it has served me very, very well, even before I had the YouTube channel. So it's not a dig on the scope. It's just I could use something in the 5-ish 100 megahertz range, maybe even a gigahertz. I satisfy the gigahertz portion with my DSA, although this scope, nowadays we can get 500 megahertz scope with 1 megohm inputs. So getting the high speed out of 50 ohms and into 1 megohms might be something I look into here in the future. So you're going to need a scope. So power supply, DMM scope. The other thing you're going to need is some form of signal source. So we have 2 function generators here and here. I would not recommend these 2 units somebody to start. They are a little expensive, but they're also the fastest of their line. Actually, no, I think there's one faster than the 4162. These were purchased specifically for a video of, are they good enough to calibrate an oscilloscope? And the answer is there is a pretty close to yes. There's some stuff that they struggle on that I had to fudge a little bit, especially with the high frequency compensation of the vertical amplifier of the scope. However, they did perform very well. I also targeted these function generators over 100 megahertz. So you can get this unit far less expensive, but it only goes up to 25 megahertz. I think that one's 160 megahertz, but it can go down to I want to say 25 or 50 if I remember the spec sheets correctly. Now, on my lab, when I need a quick and dirty signal just to push something, come on, focus camera. There we go. When I need a quick and dirty signal to shove into a circuit to see if something is working or not, I actually use this 200 a lot. I really like the sine wave it puts out. Great little unit. Very useful frequency spectrum. Easy to fix. Now, that is a vacuum tube unit. So if you're unfamiliar and you're just getting started, I would not recommend tackling a repair on that in the beginning. It has tubes in it, so we have elevated voltages. Another piece of equipment that seems to get a surprising amount of use on the bench would be this one, which is a square wave generator. I use that on scope calibrations a lot and checking a few other things. It's also one of the few units I know of that can do 108 volt square waves. However, I can get square waves and sine waves out of these 2 function generators without a problem. So in a pinch, if I'm just getting started, these 2 can replace these 2 in the beginning. And that's pretty much what I had when I was in college, doing my electronics courses in college. University, for those who aren't in the States. We had power supply, function generator, scope, and DMM. That's all you need to get started. Everything else at that point is specialization and gravy. Coming back to the breadboard here real quick. I would keep, especially in the beginning, I would keep things to possibly battery voltages under 12 volts, maybe 15, if you're going to play around with some higher power op amps. Electricity is very unforgiving, and if you crack open the wrong case, that HP 200 being one of them, there's very spicy power rails, 400, 600, 4,000 volts in some of these units. All the analog scopes that I fix, the third step in the calibration process is measure the 4,000 volt supply. I'm very used to working on high voltage. I've done it for a very long time, and I feel comfortable doing so. If you feel at all skittish or at all uncomfortable working with elevated voltages, stick to the lower voltage stuff. It can and will bite. The 106 video, actually, if you watch that one, I had a 450 volt supply go through this knuckle. So the ground rod was on this side. Negative 450 volt supply was on this side. Got zapped through the knuckle and felt it up in my shoulder. So it will bite. I even have lots of experience working on this, and every once in a while I get bit. So obviously we try to keep that to a minimum. But that's a good way to get started. Also, do not feel bad about burning up stuff on a breadboard. Especially during the learning process, resistors will smoke, chips will explode, things like that. This is not a problem. Hell, I blew up recently in the lab. I sent some op amps to the moon because I wasn't paying attention, and I wired the power rails backwards. So I put the positive rail on the negative side and the negative rail on the positive side, and the op amp exploded when I turned the power supply on. Quite literally turned into shrapnel. So thankfully I was wearing safety glasses when I hit the power supply, because a piece of the epoxy package bounced off the safety glasses, hit me in the face. Don't feel bad about burning stuff up. Everybody's done it. I've done it. Everybody who's been doing this long enough can tell you stories about when stuff went sideways in a big way. There's a trail of broken hardware behind me, and there's a trail of broken hardware behind everybody else. We do try to keep the cost to a minimum. I would prefer to blow up, 5-cent op amps and not, thousands of dollars worth of spectrum analyzer inputs. So we, all of us would like to minimize the cost of stuff that goes sideways. But don't feel bad about burning stuff up, and just also experiment. Change component values in the circuit you're playing with, things like that. See what it does. Really try to understand what each component is doing, and it'll help down the road just with knowledge. Because the problem is, I've gone so far down the road that I had a young engineer that I've been mentoring. He asked me if I had to start over again, how would I build the lab? The problem is I can't start over again, because all the knowledge I've gained during the process, I can't get rid of. Because if I didn't have that knowledge, I would have to build the lab exactly the same way I built it right now. But you could get started pretty easy going down there. Just find a rabbit hole and fall down it. Check out Elenco. The other thing you're going to need to get started is components. Elenco makes some component assortments. They have a resistor box, a diode box, and a transistor box and a capacitor box. Pick up one of each, and that should give you enough components to get started. building circuits and messing around with things, you search online. I will add some links to the description of this video. Washington State College, if I can find it, they have their ELEC1 class. I believe it's 15 or 16 hour videos where it's the college level course of going through electronics. They start with Ohm's law and end up with active components. Great introduction. YouTube is another great place to get introduction, as long as you have a well-defined BS filter. There's a lot of stuff on YouTube that is not the safest practices, so always take care and be careful. So after taking care of the basics, what's step 2? I get asked a lot. Should I buy this? Should I buy that? Do I need this? Do I need that? The best thing I found is, and I always shoot back because I have a couple of young engineers that I'm mentoring, and they asked me, one of them really asked me, should I buy a function generator? But he was playing with 555 timers and a few other things that would have self-signaling. He didn't need to drive any circuits or anything like that. And I always shot back with him, to what end? So why do you need a function generator? He would always tell me, I don't know, or seems to be what I need. If you can't articulate the need for the device, you don't need the device. Save the money till you have the whys. If somebody asked me why I needed a rubidium frequency standard for the lab, the whys are behind it. Some of them were I needed to check GPSDOs for accuracy, see how either accurate or inaccurate they even were. I needed a better clock for calibrating oscilloscopes, driving my TG501, my spectrum analyzers, things like that. My frequency counter has a very poor time base in it. Does not have the optioned up time bases in it, so its last like 5 or 6 digits were useless until I hooked it up to the external clock for the external standard. Especially when you're talking about the dollar figures, some of this stuff is having the whys behind it can help with outlaying that amount of capital. Outlaying capital without whys is a fast way to misallocate capital, let's put it that way. The one basic piece of equipment that you absolutely must not cheap out on and spend a little bit of money on it, things like that, buy a good soldering iron. The difference between a decent soldering iron and a poor soldering iron it's night and day. I've worked with some pre-university students that got a toolkit from a vocational program and had a soldering iron in it, and one of them found me and asked me and said, hey, why does my soldering suck? Nothing's taking, nothing's wetting. His soldering experience was beyond abysmal. And it was because the iron was like $2. I saw the iron that was in the kit, and I even have the same iron that was in the kit. I threw it out a long time ago. Lowest that I personally would consider acceptable would be something like a Hakko 888D. That would be the lowest I recommend. Anything above that is just gravy. Makes it even easier and soldering even more pleasant. Pace, Metcal, JBC's on the high side. I don't know if they have any inexpensive stuff. Weller, I grew up on Weller equipment, and I traded out my Weller equipment for Hakko equipment. Weller I kind of wasn't a fan of their design, some of their design choices. I still use some of their irons because I have tips and things like that for them. They're actually over at the office. I use 2 Weller stations, temperature controlled stations for repair. But they did not put a primary side fuse on the transformer. Dave Jones did a video about that on the EEV blog, where his Weller iron smoked out in the lab because there was no fuse on the primary of the transformer. Something shorted and it went south in a big way. So not a fan of that. This is going to come out after my soldering tips video, which was the lab secret sauce revealed. If you're watching this video and you haven't seen that video, I go in depth into the soldering setup. I have a nitrogen iron here in the lab. That's a special use case iron. That's here because I work on Tektronix ceramic strip. If you're not doing a lot of lead-free soldering, I wouldn't even consider it for the expense, because it is a significant expense. The iron in and of itself isn't too expensive. The nitrogen generation portion of that can be quite a capital investment. But because I have to use 3% silver solder on the ceramic strips, which is a different problem in and of itself, that's why it's here. We'll be leveraging that in a future video when I rework a LC-130. That's it for getting started. Decent scope, decent power supply, decent DMM, good soldering iron, function generator maybe. You can even build a couple of 555 timers and things like that, build a couple of circuits and get some timing sources to get going even without the function generator. So it doesn't take much to get started. Components, obviously. But as with all things, the ancillary stuff costs a ton of money, like connectors and wires and things like that. And as you ramp up in frequency, the connectors get more expensive, to the point where, depending on how high up the RF stack you go, individual couplers can be hundreds of dollars. So that's at the faster end of the pool. For the sake of this video, we're still talking about DC. Of the equipment, definitely buy the scope and the DMM new. If you have the scope and the DMM new, you could even fix a function generator. You can at least sanity check a function generator. It may not be perfectly in spec, but you at least know it's giving you out a sine wave. So you can start using secondary market gear to keep the cost down. Obviously, with a DMM and a power and a scope, you can fix power supply, do a couple things like that. Now, if you talk about opening up power supply, that's especially if you're getting started and building a lab up for the first time, find somebody in the area. Check out some of the ham radio guys. They love helping people out get started. They'll be able to point you they will definitely be able to point you in the direction of one or two people that can help you get a power supply up off the ground. The problem with power supplies is they're mains derived, so as soon as you open the case, you're exposed to mains voltages, so take care. There's 15 amps of current at the power plug, at least in my neck of the world. So I hope that answers some questions. Hope that helps some people get started. If there is any questions, comments, I will be in the comments sections in between videos. As always, more is always on the way. Check me out over on Patreon. There's some Patreon perks. Also, Patreons are 3 weeks ahead on the YouTube release videos. So nothing is behind the paywall as of yet. But they do get the videos 3 weeks early. Any money raised in support goes right back into the lab to make more videos, get more content out there, and make sure I'm making videos that everybody wants to see. So, as always, like, share, subscribe, and I will see everybody in the next video.